Okay, I have a little example here just to give you an introduction to the concept of parametric equations. Here's the mode button. You can see this is the emulator on my laptop, so it's a little bit different maybe than the actual screen you'll see, but here we have function mode, and then this is parametric, polar, and sequential. So I've switched. You can just mouse down and select what it is you want, so I selected parametric. So just go back, remember to go back when you are done with it. When you go to the y equals, you'll see that we're not, y1 and y2 and y3. Now we're x1 with a sub t there, telling you that the variable now you're typing in is a t. So I put in 3 parametric pairs of equations. Each one governs just one variable. So in this very first one, you can see with the equation signs, equal sign here, this is the only one that will graph in blue. That is 20t minus 18. So t is going to stand for time in this example. So when t is 0, we're at negative 18. That'll be 18 units to the left of 0. And you'll see I just put this in a different order, just I guess for no real reason, but it does not make a difference. It could have been negative 4t plus 27. However, it's 27 minus 4t. As t advances, you'll see this will become larger negative. When I go to the graph of this, well, let me just take you to the window first. You will see that here we have our minimum t value and our maximum t value. This is a short scenario taking place over 1.2 seconds. So the step is going to be quite small. That'll be 20 steps per 1 second. You have to be careful because the default on this is sometimes 7.5 because we're often going through a small angle with degrees, and 7 degrees is relatively small. My x minimum value is negative 20, so that'll be the left-hand boundary of my window. My max my x is 10, so it'll be the right-hand boundary. And the scale is going to be 10. You'll see that this is supposed to be what's happening on a football field, so I've got 10-yard markers. And my y values here, my y minimum is 10, my y maximum is 30. And here I made the scale large so it doesn't show up. I could just as easily have made that 0. So here's the graph, okay? I think if you remember it was like negative 18 and 27, I think, something like that. So if I go trace, you'll see that down here is where t is 0, I'm at negative 18 and positive 27. As I advance the arrow, that is making time go ahead. It is not steering my little cursor there to go to the right. It's advancing t, so you have to be ready for that. So what this is supposed to be is this is supposed to be a quarterback throwing a pass, and here's the trajectory of the football. It's going at about 20 meters per second, so it's moving quite quickly. So in 1 second, it moves 20 meters, and we're starting at, what, about negative 18. So the quarterback has dropped back and is throwing a pass. All right. The next equation, if you go back, we're going to turn on is the lower one. This is supposed to be the receiver. So I just mouse over to the equal sign and hit enter, turn that on. This will be in, oops, that's in red. I meant to turn that one below it on. So there it is, that one I meant to turn on. So that's going to be minus 5t plus minus 5 plus 5t, and then 14 plus 3t squared. Okay, so the y variable is going to accelerate. So this is meant to be a receiver that's accelerating in the y direction. And so here's the graph. And so here's the football being thrown. Here's the receiver that stalls for a little bit and then sprints towards the goal line. To trace, here you can see us go, trace, I'm going forward. If I down arrow, I'll get to the other graph. And again, I'm going forward, and you can see here's the receiver stalling and then accelerating towards the path of the football. Now with parametric, we can see, are they in sync? Is the football being thrown at about the same time that the receiver is going to get to the spot? So let me backtrack a little bit and go up. So there's the football coming in. 20th of a second later, it's there. 20th of a second later, it's there. So if I go down, that's where the receiver is. Go back up to the ball. Go forward in time, 2 clicks. Go down. It looks like they're coming pretty close in. Here's right at the goal line, and right down there, that's the receiver. So the receiver should be within diving distance, perhaps, of that ball, or getting close. And especially if I go 1 step forward, it looks like Yep, right about there. So this isn't maybe perfect, but that's about it. Now, suppose we add a third player, a defensive player. Go back to this. Here's our red. Go down and turn this one on. This player is coming from the right-hand side and is moving towards that same trajectory, that same thrown football. And here's, whoops, I must not have turned it on correctly. I did not hit the equal sign with the enter properly, so I turn that on with the enter. Now all those equal signs are turned on, so here's the graph. All right, so here is the defensive player trying to intercept that football, and if I go back to trace, you'll see here's the football coming in. We know that the receiver is trying to catch it. If I jump down, there's the player trying to intercept it. If I go forward in time right there and then go back to there's the football that's been thrown, and there's the receiver. So you can see at this instant the red line, I think, is just ahead of the receiving line. So there and there. Anyway, so I think if we zoomed in a little bit, we could change the window to zoom in on this. I don't know, can you do zoom box? I think you can. Zoom box, enter. And so I can draw a little box around this. Get my lower left corner, hit enter. It will not change, I think, the T window much, so I'll have to be careful there. And I'll go through this pretty quickly, but just to zoom in to see what's exactly happening. A zoom box like that, hit enter. And now we're zoomed into this. All right, well, thankfully our tracing is, well, this is freaking out the calculator a little bit. There we go. Maybe it's made the T steps smaller. That would be interesting if as we zoom in, it makes the T steps smaller. Oh, I'm sorry, I didn't hit the trace button. I was still doing a new zoom box. If you select zoom box and then you, here comes our football. Oh yeah, so I need to make the T steps smaller, but you can see there's a pretty big jump from right there to right there on the goal line. Where's the other player? Back there, and whoa. So we need to go, yeah, there's the receiver coming in. So that receiver is a little bit late, right? If I go back to there and then I jump up, there's the interception, and there's the ball that will have gone by. So maybe the red line will have jumped out to catch that ball. All right, that is a little snapshot on 3 parametric equations. A lot of times we're not imagining we're seeing like football play from the Goodyear blimp. We are looking at maybe a trajectory, some particle that is being thrown. If I go to my pen here, whoop, and select pen. Okay, that's not cooperating. Well, I guess I'm going to punt on this one. I still have not got my tech stuff down, but you can often model parametric equations that are for particles in motion, and you have a here we go. Here we go. Yeah, you have a particle that's moving that way according to some equation for x, and then you've got the particle going up and down, some equation describing the y, and by combining them you get the actual path of the projectile, which is going up and then coming down as it goes in a parabolic flight plan. So parametric equations, there's a start.